Welcome to Enots Engineering, I'm Alan. Today I'm making a new tool height adjusting screw for the tool holder I had. The tool holder was a copy of the original Oxford one. We put a diamond knurl on the top, and this diamond knurl, I haven't gone full depth, so I haven't formed the diamonds fully, because when the diamonds are fully formed they create a sharp edge and it's not very comfortable to hold. So let's go into the workshop and see how we do it. It sticks out 4 or 5 inches from the chuck, so I expect there'll be a bit of vibration. Make sure it's running true in the chuck. I've just got my tool holder with dial indicator fixed to a bar which we made in a previous video. Just drops into the post and locks. I can bring it in on the part, rotate the part by hand. So select the highest jaw, which is this one. Slacken the opposite side. Tighten this side up. And try and halve the error. Just tighten all the jaws. That's running within a thou. I expect it to be probably worse down this end. There we go. What I want to make today, it's the height adjustment to the tool post. This one is a Far Eastern copy of this, and I found that the diameter on this is about 1.5 millimeters smaller, which means when it goes into this slot, when you lock the tool up, just touching on the edge, I want it to go further in so it's got a positive lock. This one being a copy has a metric thread. The original ones I have BSW thread. The copy is a little taller, which doesn't make any difference really, just a bit easier to adjust. You haven't got the screws in the way. So I want to make a copy of that with the metric thread for my metric tool holder with just a bigger diameter. The thread on here is an 8mm by 1.25 pitch, and at the same time as I make the new one I want to mark a line on the top so I can see where it's set to. So I've put a 6.5mm drill in the tailstock, and I need to go in 25mm deep. I've changed my drill for a 1764 drill, which is nearly 6.7mm. So with this tap I will need to go past the threads at least to get to the full depth. I fitted my spring-loaded tap guide in the tailstock, and I fitted on the rear of the headstock the handle so I can turn the headstock by hand. I've just changed the tap for the bottoming tap, so I know the thread will go right to the end. And before I go any deeper, I want to prepare this end to put the knurl, because if I go down to 12mm, that only leaves 4mm, 2mm on each side of the hole to hold that. And I know when I put the knurl on, it's going to put a lot of pressure on this side of the job. So I'll put the knurl on next. I'll just put a chamfer on the inside. On the original screws, the knurl's a straight cut, and on the Chinese, it's a diamond knurl. I could do either. This knurling tool, which was made out of an old tungsten carbide braze bit, and all I did was cut a slot in it, put a 6mm cap head through so it would rotate. With a straight knurl, you only need one knurling tool. With a diamond knurl, you have two tools. One puts the cut one way, the other puts it the other way. When I say cut, you're actually compressing the material into the shape of the knurl. The first thing I always do is make sure you've got no bits of material left in from the previous one. Give these a wire brush to get all the bits out. Otherwise, all you'll be doing is crushing bits of swarf into the job. I'll just use a little wire brush, give the knurling rollers a brush. This tool is adjustable, so it will adjust if you're above or below centre. You also need to put some oil on these, because as it's knurling, it needs a bit of lubrication on the rollers inside. Because it hasn't got this type of knurling with the wheels there, where these come in as you tighten it up, this dissipates the force each side of to each wheel, so you're actually clamping the part between the two wheels. With this one, as you're putting the cut on, as you're feeding in to the part, you're pushing the part away. So to help the lathe, what I've done is put my revolving centre in the tailstock. I'll lock the revolving centre up on that to help dissipate the force between the tailstock and the headstock bearings. Just check that it's square. If the compound slides fully forward this direction, you're putting a lot of leverage on the compound slide, so the closer you get the tool to the centre of the compound slide, the less leverage you're putting on the clamping nuts that hold the compound slide. So I'll just put that on, get it in the centre. So I've just selected the slowest speed, which is 210 RPM. Just make sure that the centre is engaged. I'm just going to feed this in. Now I can hear them part rubbing, and you can see now one is cutting more than the other, and it's cutting on this side. So although I set it square, it wants to be twisted slightly. So the top roller now is cut right the way across. Just feed it in, see how we go. Now when you cut a knurl, don't panic if it doesn't look right first of all. What you have to do is cut the knurl until the knurl has got the full form. As you press into the material, the knurling diameter is reducing, so you're getting fewer, if you like, teeth on the part you're making. So sometimes it looks a complete mess, but as you put more and more pressure on and you go in deeper, it sorts itself out, and once it gets the teeth on the knurling tool in the groove that the teeth on the part, it'll then start producing the knurl properly. So eventually the knurl will form. If one side's cutting more than the other, either higher or lower your tool so that the other wheel comes in, so they're both pressing on equally. And frequently use your wire brush to take off the bits and pieces of swarf. Now that knurl, I'm happy with that. That's okay. I could do it more, but if I go too deep, all I'm doing is putting a sharp point on these, so I'll rub that over with some emery just to take any sharp edges off. So that's the knurling done. Now because I've put a knurl on there, what I've done is actually put a sharp edge on both sides, because the diamond pattern has pushed out material to both edges. I'm just going to re-chamfer the two sides. I've reset that to finish this diameter off inside. $12.40, so I'll leave it at $12.42, do the other side and then finish off. $12.44. So now I've got both sides to the right depth, I can straighten the tool up. $12.44. If this is too big, it will foul on the cam on the tool post. If it's too small, you risk cutting into the thread, which is 8mm, so you've got about 2mm each side of the thread on that. So we finished the head, we finished the centre, so the next job is to form the base, which is 3mm wide. Now I've changed the tool for my parting off tool. This tool has a 3mm wide tip, so I'll touch the tip on the side, zero my compound slide, wind it out and move it in 6mm. I've slowed the speed down, see how this cuts, and I'm steadying the end with the revolving centre. Try it slower. So now we've cut that off, the next job Just face this off and chamfer the edge. I've just held an 8mm cap head in the 3-jaw chuck. I'm screwing this up so that the face of this knurl part touches the chuck jaws, which should straighten it up. Let's see how that's running. So, okay, so all I want to do is face this off now on the front, check the width. We're aiming for 3mm, half a mil to come off the front. So that'll do, 295. And all I need to do is put chamfer on the outside edge. Here's the one we've just made. The only difference is it's got a slightly bigger head, and the diameter should be 21-23. I think I wanted it a millimetre bigger. 22. Here's the screw we've just made, fitted to the tool holder. That just drops inside there, locks in position. Easy to move up and down. And you can see down the side here there's about 2mm now under the cam that locks it in position. So I'm happy with that one. Here's another one I made. This time I put a straight knurl. What I have now is the thread cutting tool in the tool post, but it's on its side, so I'm just using the point of the thread cutting tool. So I'll come in, just touch the face, wind out, set it to 0 on the compound slide, go in 0.1 millimetre, go across the face, and then halfway across the other side. Scribe a mark. So you can see the full line and a half line. And the reason for that is if you're doing milling, if you're holding something in here to mill it in the lathe, you've got an idea of how much cut you're putting on. If you know what the thread pitch is, this one is a 1.25mm thread, so I know one division is 1.25, half a division is 0.625. It gives you an idea where the tool height is on the thread, and then if you want to move it, lower it a millimetre, you know it's virtually one turn. What I find is when you put the same tool in the lathe, the position of the line will be, when it's on centre, will virtually be in the same position. So there's two on the right that I've just made, one on the left that was an original Chinese copy. The difference between the two on the right is one's got a straight knurl, one's got a diamond knurl. Well, that's it for today. I hope that was useful. Hope you enjoyed it, and we'll see you next time on Enots Engineering.